Okay, now it's time to talk about IEEE 754 floating point number standard. IEEE 754 floating point number standard, and in this notation F sub 2 comma IEEE. Okay, so in our book, in our class, we focus on this single precision substandard. Okay, single precision substandard. In our class, the single precision consists of totally 32 bits. 32 bits, and side bit is 1, the exponent is 8, therefore the fraction is 23. Fraction or y sub 2. Fraction. This part, remember, we used to call it decimal part, but in the standard we call it fraction. Okay, so here it's going to be y minus 1, y minus 2, y minus 3, all the way to y sub minus m. Alright, and in our single precision substandard, m is 23. Okay, and in this portion, I would like to emphasize that this part is the fraction y sub 10. So it's sub 10 because it can be converted to base 10. Okay, and if we plus 1 plus sub 10 plus 1 base 10 is going to be greater than or equal to 1.0 but less than 2.0. Okay, and we put the absolute because this part can be positive or negative, and we call this 1 plus fraction, we call it the significand. Okay, significand. 1 plus fraction, we also call it significand. And I would like to jump here so that you can understand the standard easily. If you remember, y sub minus 1 all the way to y sub minus m, this is what we call fraction. Plus 1, so all the way plus 1, we call it significand. Remember? And the whole part can be multiplied with the side part times 2 to the exponent of IEEE of 2 base 2 IEEE subtract e by s. Okay, this e by s is a constant number. In our class, in our substandard, it's equal to 127 base 10. Okay, and this all together can be converted to base 10 according to the standard. Okay, and in the next example, I would like to show you the base 16 number. Okay, we make it short. Instead of 32 bits here, we compress it to be 16 bit. Base 16. So 4 is here, 0, 1, 0, 0. 2 is here, 2, 8, 0, 0, 0, 0. Okay, and convert this to base 10. So what should it be? If you recall, this is the psi bit, and the following 8 bits correspond to the exponent e sub 2 I triple E, and the rest is 23 bits. This is y sub 2 I triple E. Okay, and we can rewrite it here, y sub 2, e sub 2, and psi bit. Okay, and as you can see, this is the plus sign. E sub 2 I triple E equals to 1, 0, 0, 0, 0, 1, 0, 0, which is this part, 1, 0, 0, 0, 0, 1, 0, 0. Okay, for 8 bits here. So we copy them here. Okay, and 23 bits y sub 2 as well. Now, let's subtract this number by 127, which is the bias here. So 1, 0, 0, 0, 0, 1, 0, 0 is 132. Subtract the bias, which is 127, so it's going to be 5 base 10. And the fraction is 0, 1, 0, 1, 0, 0, all the way. And we change it to be the significand. Okay, so we add one more here, followed by the decimal point. Okay, so it's going to be 0, 1, 0, 1, 0, 0, 0. Okay, remember, plus 1. This is the, we're gonna make it normalize here. It's normalized now, and eventually it's going to be minus 1 to the 0, which is the psi bit, times 1 plus 0.0101 and 0, 0, we ignore them, times 2 to the 5. And as you learned in the previous example, we have to change this exponent to be 0. Okay, therefore we shift the decimal point to the right hand side, 1, 2, 3, 4, 5. Okay, so we add 0 more, and the decimal point is here, followed by 0, times 2 to the 0. Okay, which is this 0. Therefore, we convert this to 32 plus 8 plus 2 and no more. Finally, the number is plus 42.0. Okay, if you remember, if you recall, we used to show you in the example. Okay, and when we declare a float variable of a equals to 42.0, like this, therefore a is going to be 4228000 base 16 inside the memory. Okay, inside the memory. All right.